All right, guys, so here's our first online video. We're going to do solving exponential equations today. So you're going to need your notes or just a blank sheet of paper, a pencil, and then a calculator. So we're going to go ahead and get started here. Remember that we said that exponentials and logarithms are inverses of each other. And so in order to solve an exponential equation, we're going to have to use a logarithm to kind of undo it or get rid of it. Okay? So anytime you see an exponential and you need some way of getting that exponent out of there, we're going to use a logarithm. We're going to take whatever the base is, so in this case 8, and then take the logarithm of each side. So I'm going to say log base 8 of 8 to the x is equal to log base 8 of 21. Because remember, what we do to one side, we have to do to the other side. Okay. Now, these will cancel out or undo each other. So on the left side, we're just going to be left with x. On the right, we have log base 8 of 21, which we can do in our calculator. If you have a calculator that can do that, that's fine. If not, remember we use change of base. So this is the same as log of 21 divided by log of 8. And when you do that in your calculator, you should get 1.464. Okay? It says to round to the nearest thousand. It's 3 places after the decimal. All right. So, our next problem here. So again, you see that x up in the exponent means I'm going to have to use a logarithm to get rid of it, but you have to get that exponential by itself first. So kind of working outside in here, I need to get that by itself. So first thing I'm going to do is add 4 to both sides. So I have 3 times 1.4 to the x equals 64. Now I need to divide by 3. And I'm just going to leave this as 64 thirds here. So then now my next step to get rid of that exponential is to take the logarithm of that base, so log base 1.4 of both sides. That will undo. So I'll have x equals this. Again, using change of base to plug this into my calculator, this is log of 64 over 3 divided by log of 1.4. When I do that in my calculator, I should get 9.095. Okay. For this next one, this one's kind of tough, and I would encourage you to go look at my filled out set of notes, because on the right side I've written the steps that you would need to follow to go through this one. I'm only going to have room to pretty much do the problem on here, so definitely go look at that. But when you have exponentials on both sides, you can't just take log base, in this case 5 or 8, because that would only get rid of one side. So what we can do is take the natural log of both sides, use our properties of logarithms to rewrite, and then eventually solve it that way. So let me show you what I mean. I'm going to take the natural log of both sides here. So natural log of 5 to the 2x minus 3 equals the natural log of 8 to the x plus 1. Now, properties of logarithms tell us that when you have an exponent like that, it can get moved out in front of the logarithm. So then this will become 2x minus 3 times the natural log of 5 equals, same thing here, move that out in front, x plus 1 times the natural log of 8. Okay? Now, natural log of 5, natural log of 8, those are just numbers, right? We're not going to change them to the number just yet. But really what I want to do here is distribute that through, multiply that number through. So that would give me 2x natural log of 5 minus 3 natural log of 5. I want to do the same thing on this side, distribute that through. So x natural log of 8 plus 1 natural log of 8, or just natural log of 8. Okay. My next step here is to get everything with an x on one side of the equation, get everything with just numbers on the other side. So I'm going to subtract this one over, and then I'm going to add this one over to the other side. So what I'm left with here, 2x natural log of 5 minus x natural log of 8 equals natural log of 8 plus 3 natural log of 5. Okay, now that I have an x on the same side here, I can take that out, use that as a GCF. So I'm going to move the x out in front, so then I'm left with just 2 natural log of 5 minus natural log of 8. This side doesn't change. And then to get x by itself, my very last step is to divide by this entire thing. 2 natural log of 5 minus natural log of 8. Now this is going to be kind of tricky because now you have to plug this entire thing into your calculator. Okay, so practice that. But I would put parentheses around the numerator and the denominator, like this, and see if you can plug that in correctly. Again, you can pause this video if you want to try that. The answer that you should get is 6.062. Okay. So again, when you see a problem that has two exponentials, okay, on either side, this is the strategy that you're going to have to use to solve that. All right. Moving on to the next one. So on this one, you have two exponentials with the same base on one side being multiplied, so we're actually going to be using our exponent rules to combine those. Remember, when you're multiplying here, we add the exponents. So on the left side, I can write this as e to the 1 minus 3x plus 5x, and then equals 2e. I'm going to go ahead and combine. So I have 1 and then negative 3x plus 5x is just plus 2x equals 2e. So now I want to get rid of that e to the 1 plus 2x. That's an exponential. So to undo it, I use a logarithm. Since the base is e, remember that that special logarithm with a base of e is called the natural log. So what I'm going to do is actually take the natural log of both sides here. These will undo, cancel out, so I'm just left with 1 plus 2x equals natural log of 2e. Now I just need to solve for x. So I'm going to subtract 1, divide by 2. So this right here is what now you need to plug into your calculator. Again, just be careful. I would do the top part first, hit enter, and then divide your answer by 2. You should get x equals 0.347. Okay. So anytime you have e as a base that you're trying to get rid of, you need to use the natural log to undo that. And then the last one here. So 1/2 to the x equals negative 2. So this one, again, it's an exponential. You want to get rid of that. So we want to use a logarithm. You would take log base 1/2 of both sides here. So this should be x equals log base 1/2 of negative 2. But remember that we cannot take the logarithm of a negative number, right? So this one is going to end up being no solution. Anytime you see that, you're trying to take the log of a negative, you can go ahead and stop right there. That does not make sense. If you think about the graph of it, that's not going to work. We can't plug in negatives, okay? All right, that is it for this lesson. The homework is at the bottom of your notes page. I'll go ahead and write it here just in case you don't have that. When you get done with your homework, you can email a picture of it to me. If you want to wait until you're done with all of your homework and email all of it at once, that's fine. Remember that technically I cannot give you a grade for this right now because we're not in school. When we get back to school, I will be able to give you a grade for it, and we still are planning on testing over this, okay? Please let me know if you have any questions. You can email me, and yeah, that's it, guys. Thanks.